이제 본 행사를 시작하도록 하겠습니다. 첫 번째 순서는 키노트 스피치입니다. 오늘 키노트 스피치를 담당해 주실 분은 MIT 슬론 스쿨 오브 매니지먼트 스캇스턴 교수님이시고요. 주제는 The Artificial Intelligence Shift Implications for Smart Regulation입니다. 이제 원래는 스캇스턴 교수님이 금일 참여를 하시려고 그랬는데요. 일정 조정이 어려워서 오늘의 키노트 스피치는 조금 독특한 형식으로 진행을 하려고 합니다. 스캇스턴 교수님과 그리고 문성욱 교수님께서 두 분이 대담을 형식으로 오늘 키노트 스피치를 미리 녹화를 하셨어요. 그래서 그 동영상을 먼저 같이 보시는 걸로 키노트 스피치를 시작하려고 합니다. 네, 그러면 영상 같이 보시겠습니다.
Hi Scott, how are you?
Very good. Hello, Sungwook. How are you?
I'm good. Thank you very much for being here. So today I'd like to introduce our data economy forum. So the purpose of this seminar is this. Big data-based AI has the potential to revolutionize the process of innovation itself. However, carelessly designed policies may hinder the realization of this potential. With this in mind, in this conference, we will discuss how policy decisions on the collection and use of data influence the firm's behavior and the welfare of customers. In particular, we will focus on why the adoption of big data-based AI differs across sectors such as financial, medical, and public service, which have broad implications for consumers and firms, and discuss relevant global trends and implications for Korean economy. As our keynote speaker, we have Professor Scott Stern, the Davis Sarnoff Professor of Management at MIT Sloan School of Management. He is a pioneer in research of innovation and entrepreneurship. We are very glad to have you here, Scott.
Thank you so much, Sungwook. And my name is Scott Stern, and thank you so much for including me in this important forum. I'm going to start with a little bit of an overview of some of the work and the research that we've done about the impact of data-based artificial intelligence, not only on immediate tasks, but on the process of innovation itself. And then I think we're going to have a little discussion that kind of looks at kind of the policy challenges and the management challenges that arise as we approach this new world. So let me get started. Oops. Great. So you can't, open a newspaper or open the web without being absolutely amazed by some of the amazing transformations that are occurring in just the last few years in the context of artificial intelligence. In fact, starting about a decade or a little bit more now ago, what you've seen is the idea that everyone kept on saying, oh, artificial intelligence is always 10 years out, to really starting to see the impact of artificial intelligence on products, services, how companies manage themselves, and as I'm going to talk about here, on innovation. Indeed, many of you might have already seen this, but if you kind of just over the last, literally month or so, there's been a new revolution in the context of what are called large language models, so-called OpenAI chat, or through GPT-3 at OpenAI. And so one of the things that these models are increasingly able to do is actually give you and actually have a natural conversation on any topic that you want in any style that you want. And so just to prepare for this little conversation we're going to have, I sort of kind of gave it a little input, write a short description of the potential for big data-based AI to revolutionize the process of innovation itself. Let's see what it came up with. Let's see. Oh, look at that. Big data and AI can by providing vast amounts of information for analyzing patterns and trends, predicting future developments, and identifying new opportunities. Can analyze customer behavior, production process, and performance to identify area for improvements. By utilizing big data and AI, businesses can design and develop products and services that better meet the needs of their customers and improve efficiency and effectiveness. My sense is that's your next keynote speaker. Right? Wow. And so the question really becomes, right, given this power, what are the implications for policymakers, for management, for citizens. What is the nature of this artificial intelligence shift, and what are its implications? The work that I'm going to talk about, in some sense, I want to say, is going to really talk about the innovation piece. I would say that a lot of it is motivated by, in some sense, a body of work that is associated with Josh Gans and Ajay Agarwal and Avi Goldfarb. And they have a great book. So I'm going to talk, but you should go download this book called Prediction Machines, The Simple Economics of Artificial Intelligence. And the thing that these authors get exactly right is they articulate exactly what it is that these new types of artificial intelligence are particularly good at. Is that these types of AI makes abundant and expensive the process of prediction. The ability to take information you have and generate information you didn't previously have. And if you just even think about the little example I just gave you, that's a very good example of something where essentially trained on a large language model, that bot is able to predict the kind of thing that somebody answering that question would like to say. I will say there's a great book. These authors also have a new book that just came out a few weeks ago that I just read, and it is just as good as the first. And together they're, I think, some of the most interesting work happening in this area. With that said, the question is, why are books like this so important? Why are we even having this conference? And the answer, in some sense, is that over the last 15 years, there's been a sea change, a shift from a world where a particular type of artificial intelligence based on neural networks went from a situation where they were much worse than human beings at even relatively simple tasks of visual classification, of writing, of grammar, to actually outperforming those tasks by outperforming humans on those very same tasks. And the question is, what is the implication of this kind of shift in the kind of rapid advance in neural networks? And so along with two co-authors, Ian Coburn and Rebecca Henderson, we sort of thought about kind of what's the nature of the shift in AI. And one part we realized is that artificial intelligence is our general purpose technology. It's our generation's general purpose technology. It's not useful in just one area, it's useful across a wide domain of areas. But more than that, or equally importantly, artificial intelligence offers the potential for a shift. It's an invention that itself can shift methods of invention. So as opposed to, for example, traditional industrial robots, which we have many in Korea, that are very designed for specific tasks, really don't affect the innovation process at all. Or even better, pick-and-place robots, which are more flexible, but don't affect the process of innovation. What deep learning does is it's simultaneously a general purpose technology and allows for an invention in the method of invention. And that has big implications for its potential impact on innovation, on society, and the choices we make as policymakers and managers. Essentially, artificial intelligence may represent a new general purpose invention for the method of invention. Right? Kind of when we think about that, when we think about that, right, artificial intelligence is now an old field, going back, essentially 70 years. People have always had this notion that once you had working electronic computers, we could make something like human intelligence. But as most of you know, that promise was not realized for many, many years. Along with Rebecca and Ian, we kind of looked at the whole field and its history. And what we realized was that most of the research in the early days were in an area called symbolic systems. That's really almost a process of making computers actually think logically, being able to actually draw inferences and basically, reason like human beings. Or very narrowly focused on robotics to do very specific tasks. There was a third domain that had a brief spurt in the 1980s, But that was actually not a central area of artificial intelligence research around neural networks and machine learning. It turns out, though, that starting in the late 2000s, starting in the late 2000s, there was a marked shift, a marked rapid uptick in the blue line, which is those publications associated with research in neural networks. Moreover, and this is really the important, is a lot of that work was actually happening outside the US. So in some sense, relative to the internet and some other technologies, mRNA technology and things like that over the last 20 years, this is an area that's much more global, real leadership for Korea and other places. And most importantly, is that the research was not just kind of abstract computer science, as had been done in the area of symbolic systems, but what we saw was the big increase, particularly starting in 2009, was applying this to a wide variety of domains, from life sciences to financial services to manufacturing to different types of domains. And in fact, what we're seeing is places where you never would think that a prediction machine, simply better algorithms, would be useful are reinventing the very process of how we innovate. So I love this particular example. This is the currently being constructed Dubai Museum of the Future. It's being designed by Buro Happold, which is a famous design and architecture firm. And what they claim is that this unique museum, this is a several, essentially billion-dollar project, that to get the materials right, they never would have been able to do that without being able to essentially take an AI-first approach to actually incorporating prediction models into their structural analysis. And so that's an exciting new thing that we see. And so essentially what we're seeing is this is not simply applying technology to existing problems. Most of the current applications that you use AI for, chatbots when you go on the internet, when maybe it helps you with your financial modeling at your office, those are applying those neural network models to today's technology. But here is we're changing how we solve problems, and we're rethinking how we build the buildings in the first place. And so the question is, what are the implications of this shift for Korean innovation, policy, and strategy? And obviously, we're going to talk about that a little bit more. But let me just kind of make a point that this is an area where Korea maintains a quite strong position. And also, there's a lot of work already been done over the last few years that really has built a national strategy for artificial intelligence. But the question is, how is Korea going to respond to this rapidly emerging area and kind of fill in the details to that policy framework? Somewhat brought up right at the beginning, and I think our conversation will focus and primarily on, in some sense, at the core of these AI models is who has access to data, data of various types, and how is data linked? And what's the role of data in shaping the possibilities of this innovation itself? And so let me kind of end on a little bit of a historical story that I think really kind of captures the essence. So back before flight, back before the Wright brothers were able to invent an airplane, one of the key questions that people had was how to create the kind of conditions, how to produce, how to kind of design something that could fly. Okay? And it turned out that there was an early aviation pioneer, Lilienthal, and you probably haven't heard of him because he made very detailed calculations in what were essentially the first wind tunnels. But unfortunately, his calculations were faulty. And so the reason you've never heard of him was that he literally died when he tried to test out his invention. The Wright brothers had the kind of insight that rather than rely on his calculations, which were published, they developed their own calculations at a much more advanced wind tunnel that allowed them to bring the data together that allowed them to overcome their experiments and failure that ultimately allowed them to achieve flight the next year. Interestingly, though, and I think we can all agree on this, is that what that wind tunnel was able to do was to give them the design parameters so they could innovate to create the possibility of flight. However, no wind tunnel was able to predict the impact of flight on the broader human experience. And I think that's where we can kind of lead this discussion as we go. And so thank you so much, and I think we'll take it from there.
Thank you so much for your insightful presentation. It's great setup for our discussion. And most of all, the last example you gave me is about cumulativeness and openness of data access is really important for innovation process. So, okay, it's great. So let me give you first question. First question is, what are some similarities and differences between innovation in the era of big data-based AI and innovation made in previous periods?
So let me answer that. It's a great question. So I think pretty key to understanding this impact is that it's very easy to overestimate its impact in the short term and very easy to underestimate its impact in the long term. And what I mean by that is when you have most of the innovations that we have, in, for example, the mRNA vaccines, right? That was a long cumulative process to get there, but ultimately they were very well designed to solve one problem, which was a pandemic. And so they were able to be scaled. Once the first product came out, it was very easy to to see its impact very closely. Now there'll be many other applications of mRNA, but that's pretty domain to life sciences, right? In contrast, AI, and particularly this shift in AI, kind of machine learning neural networks, has the feature that it can apply to many, many different types of problems. But in each case, it's going to require a human being to say, how can I reorganize my innovation process to itself account for and kind of grapple with these prediction problems I have within the process of creating new products, services, and platforms. So what's similar to that? So computers themselves were similar to that. Computers have had, of course, a very big impact on our own productivity, but arguably some of the biggest impact of computing in general, of just the ability to calculate things, has been on how we design products themselves. And many of you I know here are engineers or have experience in CAD/CAM. All of that revolution applied across many industries. So that's a very good example of something that's relatively similar. These kind of general purpose technologies that themselves can fit in the invention process. Let me add one more that I think is perhaps useful, is perhaps the most famous kind of example of a general purpose technology that was also invention in the method of invention were kind of broad areas in agriculture. For example, the development of hybrid corn, the development of genetically modified food over the last half century. Those were basic technologies over the last century that themselves revolutionized not just one crop or one thing, they revolutionized the process of how we innovate in agriculture broadly, thus transforming our food systems, which are, of course, quite fundamental for society.
Great. So yeah, so basically the GPT characteristics is kind of key characteristic of innovation that we are observing these days, right? So that actually leads to our second question. Why do you think the adoption and diffusion of this big database AI differ across sectors? Because we observe a lot of differences in across sectors, and you showed that in your previous slide that field, finance or medical, differ in terms of adoption rate, right?
Yep, absolutely. So in some sense, and once again, this goes back to it's easy to overestimate in the long term and in the short term and overestimate in the long term. specifically, what are the quick wins, the people who adopt first? Those are the people where you can put the AI in to solve a very narrow problem without changing the rest of your organization, without changing your business model, without changing other things. And so for those of you, right, I know this is very common in Korea, it's increasingly common in the US, are, you're on the internet and you get a chat bot, and that's an AI-based chat bot. That's not a real human being. They're just kind of interacting with you with predictive text with maybe some supervision in the background from a human. Well, that's a very easy solution that as people are searching for flights, you sort of throw up the chatbot to help them out with their transaction, but the rest of the transaction keeps on going exactly as it would. So you see the particular application at first are those places where you can insert a prediction model into a narrow area of the process, but not change anything else. The potential for AI is when we sort of rewire how we think about the system, not just about the narrow applications. And so when you think, so let me give you, one example. I have a colleague at MIT, Dina Katabi, and she's developed a technology that allows for essentially contactless monitoring, basically without without a device or whatever. You're just using radio waves to have very detailed imaging of people's heart rate, even their sleep patterns, their movement. So it's a radical new technology. That's using AI to make all sorts of predictions about those people's human health. But the question is, the adoption of her technology at scale requires us to shift towards a model of remote monitoring of patients rather than having them in hospitals. So in other words, the biggest impact of her technology depends on a lot of complementary changes in how we undertake clinical trials, how we monitor pharmaceutical, how we monitor patients over time, and ultimately how we sort of collect and act on health information that we're kind of collecting in our own life. Does that kind of make sense?
Fascinating examples. So that means it's like different adoption rate across sectors might suggest some difference in complementary stuff like organization and institutions and regulations and even culture, right?
Yeah, absolutely. And so we see this across a wide variety of industries. So some of you probably here in the audience are just old enough to remember the Y2K bug, right?
Okay, yeah.
Right? So interestingly, it's very often those applications that have the highest return to a big new GPT that, on the other hand, require the greatest adjustment cost.
Okay.
And so there's actually later to adopt. And so, in fact, some of what you saw with the kind of companies that kept on with mainframe computers for a long time didn't switch to client server or PCs. That was an era, that was a shift where essentially it took a long time to get the big organizational shifts, and that itself, right, was, in fact, much of that was prompted by, in fact, that Y2K bug. People said, oh, now it's time to get rid of the mainframe and bring in the new technology, the new GTPT, which at that time was personal computers.
Yeah, so it's like in order to get stock of development in AI, we need to change organization workflows and even ecosystem, right?
Yep, absolutely. Both within the firm and across firms.
Across the firm, right? Yeah, great. So then the next question, this leads to our next question. So what are some key principles that we need to consider if we want to design policies that can encourage innovation driven by this big database AI?
Well, the first, and I think it's important, and I thank you, both you and your leadership as well as everyone here. If you leave this problem to individual researchers, individual companies, they will do what's in their own interest. And obviously the implications of this are much larger. So this is not an area where we sort of figure out afterwards that there are some unanticipated consequences. We know right now that many of the implications of AI will have consequences, and we can think about policy today rather than too late to address them. And so the question is, what principles can we bring? And I know there are a number of really excellent frameworks that people have developed to kind of think about that. But I would sort of highlight a few. The first is that for big predictive models that ultimately impact decision-making, there should be a level of transparency and interpretability. So if you are being denied a loan because some big data model said you're a bad risk, you should be able to understand why that is. And so I think one of the most critical elements, and a lot of people are working on this, but a very critical element in artificial intelligence policy is to say that the people being impacted by the decisions that result from these predictions should themselves be able to understand those predictions. That's part A. The second is that that the value that while there are important advances that are being done on being able to use relatively small data sets to actually get quite impressive prediction models, it is nonetheless true that the most valuable sorts of predictions are going to come from data sets that weave together a lot of personal data, say our mobility, literally our cell phone, where we're walking, but that combined also with my credit card information, combined with my, what I'm buying, what I'm doing, and say my social network, right? And then I bring that into a data set, and I can make actually quite precise predictions about what people are about to do. I always find it amazing that social media, social network models are very good at predicting in advance whether or not you're about to break up with your significant other. Just your social network. There are some indicators that you look up your long lost loves on the internet, and then a few weeks later you say your status has changed from now single or whatever it might be. So it goes, right? And so the second part of this is that these are important consequential decisions that link together lots of information. And if that's held by a single company, which increasingly it is, and moreover, that company doesn't provide access to independent researchers, to policymakers, well, then that company has an informational advantage that can be very long-lived. And so what I would say is a second principle is, to the extent possible, for, once again, for areas that impact our most consequential decisions about our health, about our education, about essentially our decisions about finance. We want to make sure that those data sets are not cabined in any one location. Okay. And then I would add one third principle, which is that we should that the impact of AI on the innovation process itself, on our society, is likely to result not from any one discovery, but essentially a process of cumulative discovery. Now, people building on these models and comparing them. And there are domains in AI that are very good at that. Stanford in particular has a wonderful annual index now that really sort of shows you and looks at public data of what's being tracked. But there are other domains that are much more cryptic, that are much more closed, much less of an ecosystem. And so I would say that more openness that's even beyond transparency. This is about people working and collaborating across boundaries, being able to access, being able to interrogate. That's going to be an important principle for AI policy going forward.
Great. So you basically, the key three principles are transparency of model and access to data distributed various sectors and cumulativeness.
Yep, absolutely.
Okay, great. And actually that leads to our next question. Have you observed any difference among the US, EU, and China on regulatory principles on the collection and the use of data for AI?
Well, I think we know the answer to that before we even start. So this is, the first part is the European Union basically shot itself in the foot. So it has this very bulky regulation that many of you know, the GDPR. which basically its main consequence is to create a barrier to entry to startups, and means that whenever you go onto a site that has any connection to the European Union, you just have to click through a lot of buttons, but otherwise doesn't protect you because you've given your assent. So what they've done is they've created barriers to entry, created a lot of friction in the system, and ultimately there's no way that their policies are yet really protecting consumers in the way that we're talking about. Secondly, I think in the US, in China, it's pretty clear that the Chinese government has building on exactly this framework. They understand it as a prediction problem, and they are using it to exercise control, to exercise the violation of civil liberties, to exercise how people they're using it to understand and manage their population in ways that are potentially, and I think, in fact, highly coercive. The U.S., as usual, has neither shot itself in the foot nor turned into a bit more of a closed system, but it's completely inconsistent. So the U.S. has a wide variety of policies. Different agencies at this point are talking to each other almost in different languages still. There's some very good work that's being done on really developing a broad AI strategy, as has been done here, I think, in Korea. But it's fair to say that under at least the Biden administration, this is an issue, but has not been the centerpiece issue for them yet. They've been solving a bunch of other challenges. And I think as a consequence of that, there is a possibility, and I think going forward, you'll see a bunch more being done here about essentially the U.S. trying to both coordinate across countries and also really reflect some deeper principles in policy, hopefully going forward.
Right. So then what do you think are the potential source of these differences? Like political vision or technological vision or like...
So I think in the U.S., I think some of that is purely, I would say even not political in a narrow sense, but broad. I mean, the U.S., the EU, and China have different political systems, and not surprisingly, when you get this big shift, this big new technology, those are going to be used and harnessed in different ways. I think a very important aspect of it is that the U.S. and China have developed companies and innovative capacity around this specific area. So there's a tension there between the companies are lobbying the government for more permission, and then groups that are worried about the impact on consumers are kind of pushing back. The EU is hearing, I think, much more from the implications of whatever the companies do, and has less direct players in the game that are shaping policy itself.
Okay, great. Okay, thank you so much. And our last question is, Leslie, could you please give some suggestions to students and professionals on how they could adequately equip themselves in response to future development in AI and innovation?
Well, the first thing I would do is that if you have not taken the time to do more than just a drive-by, to really explore, for example, these large language models, do it. They're open. A professor at Wharton, Ethan Mollick, has a wonderful Twitter thread, and he has actually a short paper in the Harvard Business Review recently that sort of describes the sort of sea change impact that these large language models are going to have on, for example, the area of education. Now, for our students out there, I will tell you that do not, if somebody asks you to write a 1,000-word essay on why Korea and Japan have a complicated relationship, don't just go to the OpenAI and hand that in. I promise that's not going to work out in the long term for you. But I would say that there's a real challenge there. Right now, most of the education, most instructors are saying, we have to stop the students from plagiarizing. The students, of course, face a challenge there. Well, we shouldn't just be throwing away technology. We shouldn't be stopping students from using a tool. The best example, so I'm going to take a little bit of a diversion, then I'll finish up on this, is there was a moment when the electronic spreadsheet was developed. Most of you don't know this. The electronic spreadsheet was developed by Dan Bricklin, right? What we would call today, Excel or Google Sheets, was developed actually by a student, an MIT undergrad, but then was an MBA at the Harvard Business School, because he didn't want to do these tedious calculations on his problem sets. He became the most popular student because he automated it all. Well, if we are going to equip innovators, entrepreneurs, managers, leaders of tomorrow, they should be leveraging these tools. And so the question is, we need better systems to assess people on how they are expressing their own views when these tools are available, rather than banning their use or pretending not to notice when students go to the bottom. Did you see what I'm saying?
Yeah, I could agree with this.
Right. The last piece of this that I would say, which says, how do you equip yourself, is dive into a particular domain and ask yourself one question. Go through a production process. How many times when I look at the supply chain or the value chain in a particular sector, what depends on the ability to predict? Those are the areas where AI is likely to have an impact. And the question is, what are the things that are less likely to be impacted by such a prediction machine? And that itself can shape the areas where humans will continue to have a comparative advantage. Thank you so much.
Thank you. It's great.